stoichiometry, which includes the major concepts like limiting reagent, excess reagent, percentage yield, theoretical yield, empirical formula, molecular formula. We'll be discussing all these topics. Plus, along with this, one question arises in mind that what is the use of stoichiometry in real life? So, for example, let's say if you use a face wash or a shampoo, on the back of the container, you must have seen the ingredients section where it is written this contains X percentage of that compound, Y percentage of this compound. So, all these percentages, all these percentage, mass, percentage of the compounds present in the objects that you use everyday basis, all of it is calculated using stoichiometry only. One more example I can give you is the example of medicines. Medicines have a fixed fraction of different compounds inside them. So how is that fixed fraction calculated? It is calculated using stoichiometry, the calculation of moles. Now that we are clear with the fact that where is moles used, where is stoichiometry used in real life, we can start with the basics of this topic. So the basics start with moles. We need to understand what does one mole means, where is it used, why is it used. So one mole is just a unit of measurement. It is just a unit of measurement for microscopic particles. Microscopic से भी better we could say just atoms, ions, molecules, elements. इन सब के लिए mole is a measurement quantity. Just like we are aware that 1 dozen is equals to 12, 1 century is equals to 100 years, 1 quarter is equals to 1 by 4. In the same way, 1 mole is equals to 6.022 into 10 to the power 23 particles. If I'm saying 1 mole Na atoms, it means 6.022 into 10 to the power 23 Na atoms. If I'm saying 1 mole MgCl2, it means 6.022 into 10 to the power 23 molecules of MgCl2. This is what 1 mole means. Now there are various definitions of a mole. Let's study those first. So first definition you could say is that amount of substance that contains this much particles. Now these particles could be anything, atoms, ions, molecules. If it is written that 4 moles of ammonium ions are there, so find the number of ammonium ions. We'll directly say that 1 mole contains 6.022 into 10 to the power 23 ions. So 4 moles will have 4 into 6.022 into 10 to the power 23 ions. I hope all of you are getting what it means. Then there is another definition for moles in terms of volume, which says that 1 mole is equals to amount of volume occupied by 24 dm cube of gas at room temperature and pressure. So this is our another definition of moles. Now that we are clear that what is mole and what does it means, I've given you two definitions for moles. Then there comes the calculation wala part, that how do you calculate moles if mass is given? How do you calculate moles if number of particles is given? How do you calculate moles if volume is given? So I've written the formulas in such a way that it will be clear in your mind that if the question has something to do with mass, so you'll have to use this formula. If the question has something to do with particles, you'll have to use this formula. If the question has something to do with volume, you will directly use this formula. Now let's take 2-3 examples just for clarity. So let's say 48 dm cube of nitrogen gas. I'm just writing the simple questions. 48 dm cube of nitrogen gas. Find moles of nitrogen gas. So you can solve this using the definition. The definition says that 1 mole is the amount occupied by 24 dm cube of gas. Means the volume is 24 dm cube. So 1 mole is equals to 24 dm cube. In reality, you have 48 dm cube. So how much will be the moles? 2 moles. It's basic. Now, if you do not want to use this method, you can directly go with the formula which says that moles is equals to given volume by 24 dm cube. Given volume is 48, 24 dm cube. You divide both of them, you will get 2 moles. This is one way to solve these kind of questions. Then there is the part of number of particles. Let's say if 12.044 into 10 to the power 23 number of atoms are there, number of atoms of Na, let's say, are there, find moles of Na. So in this case as well, you can go with the two methods. First is you can directly remember that one mole occupies this much particles. So in this case, we are talking about atoms. So one mole will occupy this much atoms. So 1 mole is equals to 6.022 into 10 to the power 23 atoms. And in this case, they have given you 12.044 into 10 to the power 23 atoms. So directly it is a double of it. So अगर 1 mole में इतना होता है, 2 moles will have this much. So your answer directly comes out to be 2 moles. Then if you do not want to do this method, you directly want the formula. So the formula is here for you as well. Given number of particles is 12.044 into 10 to the power 23. Divide that by 6.022 into 10 to the power 23. Like this. 6.022. Cancel, cancel, cancel. So you'll be getting 2 moles. The same answer you can get using the both methods. It's totally up to you. Both methods will give you the correct and same answers. Now, then what they do is just to make the questions difficult, they will give you the mass, they can ask you the number of particles, they can give you the number of particles, they can ask you the volume, or they can ask you the given mass. Or they can give you the given volume. Let's say, for example, volume वाला हम question कर लेते हैं अभी. So it's saying that, just let me draw a black screen here. Fine. So let's say it's given that 48 dm cube of ammonia is present in a solution. Find mass occupied by ammonia. Find the number of molecules of ammonia. So here the conversion is from, they have given you the given volume, they're asking you the number of particles, and they're asking you the given mass. How to solve this kind of question? Just directly remember one thing, always find the moles first. That will help you a lot. So volume is given, and you know that 1 mole is equals to 24 dm cube, and they have given you 48 dm cube, so you must be having 2 moles of ammonia. Or you could directly use the formula as well. Given volume is 48 divided by 24, that will give you 2 moles as well. Totally up to you. The answer will stay the same. So 2 moles of ammonia we have. Now they're asking me the mass occupied. So moles we know, given mass we are trying to find out, and molar mass we can find out. See, at this point as well, यहाँ मैंने लिखा हुआ है RAM and I have written RMM. RAM means relative atomic mass, which will always be given in the periodic table, and RMM is the relative molecular mass, which you can find out from the periodic table. How? Let's say for this thing only, for ammonia only, you will look at ammonia, you will say this contains one atom of nitrogen and three atoms of hydrogen. So one atom of nitrogen has a mass of 14 grams. One atom of hydrogen has a mass of 1 gram. Now you have three atoms of hydrogen, multiply by 3, add both of them up, you will get 17 grams as the mass of ammonia. One more example, let's say CaCl2, you have to find the molar mass of this. You look at the periodic table, calcium's atomic mass is 40. Single chlorine has an atomic mass of 35.5. So 2 chlorine will have atomic mass of 71 grams. So 40 plus 71 grams, this will give you 111 grams. This is how you find out the molar mass. Now moving back to our question, So we found out the moles. We got the moles of ammonia as 2 moles and we got the mass of ammonia as 17 grams. Fine. So moles is equals to given mass by molar mass. In this case, I'll write moles are 2, given mass we have to find out, molar mass you figured out 7. So X is equals to 34 grams. This is the mass occupied by ammonia. Now, in order to find the number of particles or the number of molecules of ammonia gas, you will do the same thing. Just let me just erase it up, and I can write here that 2 moles of ammonia is equals to given number of particles by Avogadro's constant. This is the Avogadro's number. So given number of molecules will be 12.044 into 10 to the power 23 molecules of ammonia. This kind of question can be asked as well. Fine. So this was the basic moles, how to calculate moles. I've given you the 2 definitions and I've given you the 3 formulas. These are the 3 formulas for moles. Now moving ahead with stoichiometry. Now what does stoichiometry means? What is the difference between stoichiometry and moles? See, it's just one clear difference बेटा इसके अंदर कि that mole is a unit for measurement of atoms, ions, molecules, compounds. In सबके लिए moles is a measurement unit. But stoichiometry is the application of moles in chemical equations. When you apply moles in chemical equations, when you try to find out moles in chemical equations, that branch of chemistry is called as stoichiometry. And mole is just a unit. I hope it is clear to all of you. Now, how to apply stoichiometry in chemical equations? Here we'll be dealing with the ratio method, the unitary method. All of you have done the same method in maths. Unitary method, just like this thing that if 2 pens, 2 pen cost 100 rupees, so 1 pen will cost 50 rupees. This unitary method will be applying here in this case as well, but with moles. Now moles will be the unit, not the INR. Rupees won't be the unit. यहाँ पर we'll be discussing the unit as mole. So how to apply this, how to go through this? See, simply, let's say I'm writing equation Na plus HCl giving NaCl plus H2. First step should be to balance. Always balance the equation first. So 2, 2, 2, I've put it here. This will balance out the equation. Now in the question, they have given that 46 grams of Na is there. 46 grams of Na is there, noted. They're asking me find moles of NaCl, find moles of hydrogen, find volume of hydrogen gas produced. Fine. So simply what we need to do here is I'll just make a rectangular box here. So simply have a look at this. Given mass was 46 grams of sodium. So I'll write 46 here. I will check the atomic mass of sodium. This is atom of sodium. It's not a compound. So you'll directly write the atomic mass. You will look on the periodic table. You will find that sodium's atomic mass is 23. Now do not do the mistake of multiplying 23 with this 2. 2 is not the atom. Na is the only atom. So Na's atomic mass is 23. You will directly do 46 by 23. That will give you 2 moles. Then they're asking us the moles of this species and the moles of hydrogen produced. Now comes the ratio part, how to apply the ratio. So you will just look at it like this, that 2Na is giving you 2 NaCl. Now what is the ratio between both of the species? The ratio between Na and NaCl is 2 is to 2, which means 1 is to 1. Which says that if you have 10 moles of Na, you will get 10 moles of NaCl as well. But in reality, in this question, we have 2 moles of Na. So I will get 2 moles of NaCl as well. 2 moles of NaCl. This is how I found out moles of NaCl. Now, if they are asking me find moles of NaCl, find mass of NaCl. See, I figured out moles of NaCl. Now, if they ask me find mass of NaCl, Now it's just basic moles. You know the moles of NaCl. You will say moles is equals to given mass of NaCl, of course, by molar mass किसका? NaCl का. You will get the mass. 2 is equals to given mass. You look at the periodic table. Na is 23, chlorine is 35.5. So it equates to 58.5 roughly. So 58.5. So given mass will be 117 grams. This is how. Now let's say if they ask you find volume of NaCl produced, you know the moles, 2 moles, you are already aware that 1 mole carries 24 dm cube. So 2 moles will have 48 dm cube. That's it. This is what they could ask you more. Now in the same way, how will you find out hydrogen? So you'll use the ratio again. Now you will use the ratio between Na and hydrogen. So let's see. 2 Na is giving you 1 hydrogen molecule. So 1 Na will give you 1 by 2, half exactly. The ratio is going to be half because the ratio is 2 is to 1. If you had 10 moles of Na, you will be getting 5 moles of H2. If you had 100 moles of Na, you'll be getting 50 moles of H2. This is what this means. So in reality, you have 2 moles of Na. In the question, we found out 2 moles of Na because 46 grams was the mass. Divided by 23, you will get 2 moles. So now you'll be getting 1 mole of hydrogen. Basic maths. I hope this is clear to all of you. I'll repeat again. 2 Na is giving you 1 H2, means it's getting half. So if you had 100 moles of Na, you'll be getting 50 H2. If you had 500 Na, you'll be getting 250 H2. Now in reality, you have 2 moles. So uska half kya hoga? 1 mole. That is the answer. This is how you use ratio. Now that you have figured out the moles of hydrogen, you are aware that 1 mole carries 24 dm cube. So you have 1 mole only. So the volume occupied by hydrogen will be 24 dm cube only. That's it. This is how you use ratios. Now comes the limiting reactant and percentage yield part. So let's study this as well. Okay, so the theory for this, why is limiting reagent required first of all? So let's have a look at this. The same question we did, I'll prove using that only. So have a look at this. So the question that we were doing, it was giving Na reacts with HCl to form NaCl plus H2. And it was given in the question that sodium is 46 grams. Let me take HCl as 36.5 grams. Now balancing the equation is a must. So I've written 2 to 2 here. Let's find out the moles of Na. Na's moles were 2 moles. HCl's total molar mass is 36.5. So I'll get 36.5 by 36.5, which will give me 1 mole only. Now, if the ratio method that we are doing currently is correct, then according to NaCl, I should get the same mass of NaCl. And according to HCl, I should get the same moles of NaCl. I meant the moles only. Moles and mass, it should be the same according to Na and HCl. So let's try. I'll write down one statement here. यहाँ I'm trying to find out moles of NaCl using Na. And here I'll try to find out moles of NaCl using HCl, using ratio only, I mean. So have a look at this. In this case, 2 Na is giving you 2 NaCl. So the ratio is 1 is to 1. 1 Na will give you 1 NaCl. In reality, you have 2 moles, so it will give you 2 moles of NaCl. Fine. So according to Na, I am getting 2 moles of NaCl. Let's try using HCl. So 2 HCl is giving you 2 NaCl. 1 HCl will give you 1 NaCl. In reality, you have 1 mole of HCl only, so you'll be getting 1 mole of NaCl. This is a basic ratio. But now this is a problem because you cannot have two different values of a product. This is the product. Product needs to be fixed. I'm not saying product का amount ज़्यादा होना चाहिए या फिर कम होना चाहिए. It can be anything, but it should be fixed. According to Na, I'm getting 2 moles. According to HCl, I'm getting 1 moles. Now, this is where the issue arises. So, this is why we need to study the limiting region. Because limiting region is the one that will decide the amount of product formed, and it will decide the amount of reactant consumed. Now, how to figure out the limiting region? Let's take one basic example first. Let's say I have 20 slices of bread and I have 9 cheese slices, and I'm trying to make some sandwiches. So, and what I need to do is that use 2 bread slices, put 1 cheese slice in between. So, according to this, I'll be able to make only 9 sandwiches. I'm not able to make 10 sandwiches. Reason why? Which one out of these two reactants is limiting the reaction? Cheese slices. Cheese slices are limiting the reaction. Cheese slices are limiting the reaction. If cheese slices were more, then I would be getting 10 sandwiches. If the cheese slices were less, I would be getting less sandwiches. So it directly means that out of the two reactant, there should be one reactant which is present in less amount, which will determine the amount of product formed. जैसे कि इस केस में cheese slice is deciding कितने सैंडविच बन सकते हैं. If you had 10 cheese slices, you would be getting 10 sandwiches. If you have right now 9 cheese slices, you're getting 9 sandwiches. So cheese slice is deciding how much product is formed. Na? Also, at the same time, cheese slice is deciding how much reactant should be consumed. How? If you had 10 cheese slices, all the bread slices would have been consumed. Right now, you have 9 cheese slices, only 18 slices are consumed. If you had 8 cheese slices, only 16 slices of bread would have been consumed. So the statement that I've written here, it decides the amount of product formed or the amount of reactant consumed. This is why limiting reagent is required. I hope this is clear to all of you. Now, how to find out the limiting reagent in chemical equations, that we will discuss. This example I told you just to make it clear that limiting reagent का काम क्या होता है. It determines the amount of product formed and it determines the amount of reactant consumed. Okay, now after this, let's see. So, how to determine the limiting reagent in chemical equations? Have a look at this. The limiting reagent is clearly the one present in less amount. Fine. But how to find that out in chemical equations? Let's say, for example, the same equation I'm using here, जो अभी अभी हमने use करा था, 2Na plus 2HCl, giving 2NaCl plus H2. So this was coming out to be 2 moles, this was coming out to be 1 moles. Now, so according to the theory that we studied, limiting reagent is the one that is present in less amount. So we will say limiting reagent is HCl because इसके moles कम है. नहीं, this method is not right. You might get the same answer sometimes, but you will also get the wrong answer sometimes if you go using this. Limiting reagent definitely means less amount, but you have to think carefully. In this case, 2 moles are occupied by 2 molecules of Na. So if you're trying to compare the amount, compare fairly, compare per molecule. What are the moles of Na per atom? So it is 2 by 2. What are the moles of HCl per molecule? It will be 1 by 2. 2 HCl giving 1 mole. So 1 HCl will be giving 1 by 2 moles, no? This is the correct way. Now, if you just directly want a direct formula for limiting reagent, I can just tell you this: moles by stoichiometry, moles by coefficient. You can directly remember this. It means the same thing, beta. Just make sure to do moles by coefficient for both the reactants. Let's say for Na, the moles are 2 and the coefficient is 2. This is the coefficient, the one I'm circling here. This is the coefficient 2. So 2 by 2 is giving you 1. But for HCl, the moles are 1 and the coefficient is 2. So you're getting 1 by 2, which is 0.5. So HCl is the less one. HCl is less. So HCl is the limiting reagent. So the answer that you will get using HCl should be the correct answer because HCl will decide the amount of product formed. Now that we are clear that HCl is the limiting reagent, so you directly need to use the ratio, but the ratio you will use using HCl only. You won't use the ratio using Na because ये गलत है. This is the excess reagent now. Excess reagent won't help you determine anything. Limiting reagent will help you determine the moles. So then you will say 2HCl will be giving you 2NaCl. So 1HCl will be giving you 1NaCl because the ratio is 2 is to 2, which means 1 is to 1. In reality, you have 1 moles of NaCl, 1 moles of HCl, I mean. So you'll be getting 1 mole of NaCl. You better make sure to remember this thing, this formula that I'm telling you, you do not have to use this anywhere else. It is just used for finding out the limiting region. It won't be used for calculations purpose. For calculation, you will directly use the ratio method using 1 moles. See, I have not written 1 by 2 here. I have written 1 HCl giving 1 NaCl. So 1 mole will give him 1 mole of NaCl. I'm not using 1 by 2. 1 by 2 and this 2 by 2, they were just helping me to figure out what is the limiting region. That's it. Now that I'm aware that HCl is the limiting region, I'll directly use the ratio. 2 HCl giving me 2 NaCl, 1 HCl will give me 1 NaCl. In reality, I have 1 moles of HCl, so I'll be getting 1 moles of NaCl as well. That's it. Khatam. So this was all about limiting reagent. Now, the theory I've written here that reactant present in less amount, simplest way to find limiting reagent is check moles by coefficient for all the reactants. Reactant having less value is the limiting reagent that will decide the amount of product formed, amount of reactant consumed. This is about limiting reactant. Now, percentage yield is also given here, so let's discuss that as well. See, percentage yield directly means actual yield by theoretical yield into 100. Now, what is actual yield, theoretical yield? Actual yield is the one which is always given in the question, and theoretical is the one that you find out using stoichiometry. What does this means? Let's do a question for this. See, this question, let me just find one question here and we'll try to solve that out. Always remember actual yield is given in the question, theoretical is the one that you find out using stoichiometry. So let's find out one question for limiting region for percentage yield. Okay, so let's try this question that Praneel reacted 48 grams of magnesium and produced 150 grams of MgSO4. Find the percentage yield. Fine. So first of all, we need to write the equation Mg plus H2SO4 giving MgSO4 plus H2. Mg is 48 grams. So we'll do given mass by atomic mass of Mg, which is 24. You'll be getting 2 moles. Also, this equation is balanced. It should be balanced, but this one is already balanced, so no need to balance it. And see, now clearly they're saying Praneel reacted this much grams of Mg with H2SO4 and produced 150 grams of MgSO4. So this is produced. So this is the actual yield I was talking about. Actual yield will always be given in the question. Yield means produce, the amount of product formed. So this is always given in the question. And theoretical yield for MgSO4 you will find out using the stoichiometry. The amount or the mass of the product that we find out using stoichiometry, that is the theoretical yield only. Now, Mg is 2 moles. I need to find out the moles of MgSO4 first. I'll look at the ratio. 1 Mg is producing 1 MgSO4. So in reality, we have 2 moles of Mg. Means I'll be getting 2 moles of MgSO4. Fine. So this is 2 moles of MgSO4. Now that you know the moles of MgSO4, you can directly apply the formula for mass. That 2 moles is equals to given mass by molecular mass. So 2 is equals to given mass that we are trying to find out. This given mass will be the theoretical yield. But I'm repeating again, actual yield is given in the question. Theoretical yield is the one जो आप ratio apply करके find out करते हो mass. That is the theoretical yield. यहाँ पर मैंने Mg and MgSO4 में ratio apply करा. I applied the ratio between Mg and MgSO4 where I first found out the moles. Now I'm trying to find out the mass of MgSO4. So that will be the theoretical yield. Now the molar mass of MgSO4, let's see. So the molar mass of MgSO4 is 120 grams. So 2 is equals to x upon 120. So the theoretical yield is coming out to be 240 grams. Fine. I hope यहाँ तक सभी को सारे steps clear है. All the steps are clear to you. Now you have to find the percentage yield. Actual yield was already given in the question. We just needed to find the theoretical yield, and we already have the theoretical yield now, which is 240. So directly I will do 150 by 240 into 100. Let's use the calculator. 150 divided by 240 into 100, which is 62.5%. So the percentage yield in this case is 62.5%. Theoretical yield is the one that you find out using stoichiometry. Okay, now moving on to the next topic. We're done with limiting reactant, we're done with percentage yield. Now, we have to study this topic, which is empirical formula and molecular formula. Fine. So this is the simplest topic of stoichiometry. See, throughout our childhood, we have been studying about glucose. C6H12O6. This is glucose. Now, if you think about this, C6H12O6, we can try to simplify this compound. If we divide this by 6, we'll be getting CH2. Now, question, can we simplify it even further? Let's try. If you divide it by 2 again, let's say you're trying. So, carbon will be converted to zero point 0.5. Hydrogen will be 1, fine, no issues, but oxygen will be again converted to zero point 0.5. Atoms cannot be into decimals. So, this is the most that you can convert it. Divide by 6, you'll be getting CH2, that's it. इससे ज़्यादा नहीं हो सकता. इससे ज़्यादा अगर आप करने की कोशिश करोगे, you'll be getting the decimals, atoms and decimals, which is not possible. Atoms cannot exist in decimals or fractions. Atoms can exist as whole numbers, 1, 2, 3, 4, 5, 6, 7, 8, so on. So this is the simplest you could make it. So right now, what we did is, we had a molecular formula. This is the molecular formula. We divided it with a certain number that gave us the CH2O, which is the simplest formula. We cannot simplify it even further. So this simplest formula is called as the empirical formula only. Nothing too complicated. एक molecular formula होता है, आप उसे simplify कर देते हो using some number to divide, then you get the empirical formula. One, two more examples, let's say. They have given you C2H4. You can divide it with 2 to get CH2. And you cannot simplify CH2 further. So CH2 is the empirical formula. C2H4 was the molecular formula. Now let's say they've given you C4H10. So divide by 2, you'll be getting C2H5. You cannot simplify it further. If you try to simplify it further, hydrogen will be converted into a decimal. And hydrogen cannot be in a decimal format. Atoms cannot be in decimals. So this was the molecular formula. This was the empirical formula. Now question, will they give us questions like this? They won't. What they will give you is that ये जो empirical formula है ना, इसमें carbon का percentage is this much, hydrogen's percentage is this much. Tell me the empirical formula. So a same question like this I have written here, that there was some compound CXHYOZ, not sure how much carbon it will have, how much hydrogen it had, or how much oxygen it had. But there was this compound, and the composition they have given us, they're asking us to find out the empirical formula of this compound. So there are n number of methods to solve these kind of questions, but we'll be solving it using the simplest one. The simplest one is this method, that you look at the percentages. The percentages will add up to be 100%. If you try to combine these percentages, they will add up to be 100%. So your first step should be that convert the percentage to grams. So 52.4% की जगह I have written 52.14 grams. 13.13%, in place of that I've written 13.13 grams. Same for oxygen. Now that you know the mass of carbon, you know the mass of hydrogen, you know the mass of oxygen, you can simply divide with the atomic mass to get the moles. So 52.4 divided by the atomic mass of carbon, 12. I'll be getting this. 13.3 divided by atomic mass of hydrogen. Now this is hydrogen atom. So hydrogen atom is 1 grams only. 13.13. 34.73 divided by 16, it is giving me 2.17. So these are the moles of oxygen, hydrogen, and carbon respectively. Then empirical formula is the simplest formula. Right now you only know the moles of carbon, hydrogen, oxygen. So what we do is we will directly divide all the three with the simplest moles to get the simplest ratio. I hope you're getting what this means. Divide the moles with the simplest moles, smallest moles I mean, to get the simplest ratio. Now the smallest moles are of oxygen. So if we divide 4.345 by 2.17, you'll be getting 2. If you divide 13.13 by 2.17, you'll be getting 6. If you divide oxygen 2.17 by 2.17, you'll be getting 1. So the simplest ratio of carbon is 2, simplest ratio of hydrogen is 6, simplest ratio of oxygen is 1. So your empirical formula is C2, hydrogen is 6, oxygen is 1. That's it. Beta, for your reference, I've written the steps here as well. परसेंटेज को ग्राम में कन्वर्ट कीजिए, डिवाइड द मास बाय एटॉमिक मास टू गेट द मोल्स, divide moles with the smallest moles to get the simplest ratio, get the smallest whole number ratio. That's it. Now that you have calculated the empirical formula, they ask us the molecular formula as well. It could be asked that what is the molecular formula? So for molecular formula, you will need the molar mass, which is given as well. In this question, it is 138.2 grams per mole. Now, have a look at this. What you need to do is just simply understand this. Empirical formula mass, if you calculate, it will be 12 times 2 plus 6 plus 1, which is coming out to be 46 grams. Now see, empirical formula mass is 46, molecular mass is 138.2. If you divide them, you'll be getting 3. So 3 is the conversion factor between the empirical formula and molecular formula. Now, empirical formula is the smallest formula, simplest formula. So you will have to multiply the empirical formula with molecular formula. So you will multiply C2H6O1 with 3 to get C6H18O3. This is the molecular formula. I'll repeat the steps again. Empirical formula is easier to find, but sometimes students do feel confused in how to find out the molecular formula. There's this simple step. If you know the empirical formula, find out the mass of empirical formula. In this case, it came out to be 46 grams. And the mass of molar formula or the molecular formula mass is already given. You divide both of them, you will get a whole number which is 3. Multiply that whole number with empirical formula, you will get the molecular formula. That's it. Now we can practice one more question for this as well, just for conceptual clarity. So I'll write down the question here. Just give me 1 minute. First of all, let me find a question. Hmm. Let's say this is given that 20.2% sodium, 37.6% sulfur, and 42.2% oxygen is there. The molar mass they're telling us is 682 grams per mole. Find the molecular formula, find the empirical formula. बिल्कुल same question. Really simple question. Convert the percentage directly into mass. So this will be 20.2 grams by the atomic mass of Na, which is 23, 36.6, 37.6 grams by the atomic mass of sulfur, which is 32 grams, 42.2 grams of oxygen divided by 16 grams. So this will give us the moles. Let me just calculate how much that will be. So 20.2 divided by 23 is coming out to be 0.878. Fine. These are the moles of Na. 37.6 divided by 32 is coming out to be 1.175. These are the moles of sulfur. Then 42.2 grams divided by 16 grams is coming out to be 2.637. So these are the moles. Then we had to divide the moles with the smallest moles to get the simplest ratio. The steps are written here in front of you. I'm doing the same thing. So the smallest moles are of Na, which is 0.878. So divide this with the same thing. Divide this with 0.878. Divide this with 0.878 as well. So this will give you a ratio of 1. And 1.175 divided by 0.878 is coming out to be 1.33. And 2.637 divided by 0.878 should come out to be around 3.003. So this can be written nearby equal to 3 only. This is 1 only, but you cannot write this as 1.5 or 1. Not possible. So now, see, we are almost done with the question. Only the issue is we are not getting a whole number for sulfur. For sodium, we are getting a whole number 1. For oxygen, we are getting a whole number 3. But sulfur, we are getting 1.3. Sulfur cannot be 1.33. atoms cannot be in the form of decimals or fractions. It has to be a whole number. So now we have to think of a number that we will multiply all of them, all three of them with, to get the whole number ratio. If I try multiplying with 2, with 2, with 2, I'll be getting 2 here, I'll be getting 2.66 here, I'll be getting 6 here. Sodium and oxygen were already fine, they're still fine as well, but sulfur is not. Still we are getting the whole ratio, still we are getting the decimal. So let's try multiplying all of them with 3. So this is 3. Now this is, if you multiply by 3, you'll be getting 3.99, which equates to 4. And 3 times 3 will be 9. So now we are getting a whole number ratio. Means Na3S4O9. Question khatam. That's it. This is how you find out the empirical formula. Now that you know the empirical formula, they're asking us the molar mass or the molecular formula, sorry. Molar mass is already given. Empirical formula, you have calculated Na3S4O9 and molar mass is already given, which is 682 grams per mole. So let's calculate the empirical formula mass, the mass of this compound. This was O9. So 3 into 23 plus 4 into 32 plus 9 into 16. It is coming out to be around 341. You guys can check in your calculator as well. So it will come out to be 341 grams. Now check. Empirical formula has a mass of this much. Molar formula has a mass of this much. There is a direct relation between both of them. Direct ratio of 2. 1 is to 2 का ratio है. So you'll multiply the empirical formula with 2. You'll be getting Na6S8O18. Na6S8O18. Yes, this is the correct answer. I hope this is clear to all of you. We have done 2 questions for empirical formula, molecular formula. These are the kind of questions that is asked in our exams. Okay, now after this, there is just one more topic remaining, which is the titration calculations part. So the topic is titrations calculations. Titration calculations. Now, first point, what does titration means? When you're reacting an acid with a base, you'll be getting salt plus water. We have studied this under acid basis salts. Acid plus base is equals to neutralization reaction. It gives us salt plus water. Now, why is it used in stoichiometry? Then, what kind of questions they will ask you? In stoichiometry, I'll directly tell you the kind of questions they will ask you. So, for the acid, volume will be given and volume will be given for base as well. So volume will be given for both of them. Then concentration will be given for either of them. Base का concentration given होगा या फिर acid का concentration given होगा. They will ask us to find out the concentration of the other species. So first of all, concentration is equals to moles by volume. Volume should always be in decimeter cube. If it is given in centimeter cube, divide by 1000 to get decimeter cube. Fine. This is how to find out the concentration, and moles you can always find out. So let's do a sample question of this titration calculations. Let's say HCl reacted with NaOH to form NaCl H2O. Now in the question it was given that 20 centimeter cube of HCl reacts with 30 centimeter cube of NaOH, whose NaOH concentration is 0.01. 0.01 mole per dm cube. And we have to find out moles of HCl and concentration of HCl. So what we directly need to do is, for NaOH, we are aware about the volume and we are aware about the concentration as well. Now, if you look at the formula of concentration, it is moles by volume. So we know the volume, we know the concentration, we can directly find out the moles of NaOH. So 0.01, which is the concentration, is equals to moles. We are not aware. By volume, we are aware, but we'll have to convert the volume into dm cube. So 30 by 1000 giving 0.03 dm cube. So I'll have to write 0.03 here. So moles of NaOH will be 0.0003. Fine. Now that we know the moles of NaOH, we'll check the equation is balanced or not. It is already balanced. So the ratio between NaOH and HCl is 1:1. So if you have 0.0003 moles of NaOH, one NaOH is giving you one HCl. They are reacting in 1:1 ka ratio. So 0.0003 NaOH will be giving you 0.0003 HCl. So the moles of HCl is 0.0003. Then they're asking us the concentration of HCl. So concentration is moles by volume. Moles, you know, and volume was already given. You'll have to convert this into dm cube, so 0.02 dm cube. And moles of HCl you have also found out 0.003. So we'll do concentration is equals to moles, which is 0.0003 by 0.02. This will give you the moles of HCl as well. Let's check. 0.0003 divided by 0.02. The moles are coming out to be 0.015. That's it. This is the way to go about these questions. Now I'll summarize this again. Titration means acid plus base reacting with salt to form H2O. Now in the questions, in stoichiometry questions, they will directly give you the volume of both the species and concentration of either the base or the acid will be given. And they will ask you the moles of the other species, concentration of the other species. It is usually framed like this. The general pattern of the question is like this only. So in the question, we were given 20 centimeter cube of HCl and we were given with 30 centimeter cube of NaOH as well. The concentration of NaOH was given, which was 0.01 moles per dm cube. So first what I did is I calculated the moles of NaOH using the formula that concentration is equals to moles by volume and volume should be in dm cube. So we converted 30 centimeter cube to dm cube, which is 30 by 1000, so 0.03 dm cube. Then we knew the volume, we knew the concentration, we multiplied both of them to get the moles of NaOH, which came out to be 0.0003. Then I looked at the ratio between NaOH and HCl, the ratio was 1:1. So we would have the same moles of NaOH and HCl. So we'll be getting moles of HCl as 0.0003 as well. Now that we know the moles of HCl, we are already aware about that volume. So we'll directly do moles by volume. Volume should be in dm cube as well. So I divided both of them. I got the moles as 0.015. This is the way to solve these questions, and the general pattern of these questions is always like this. So we by now we have done titration calculations, we have done empirical formula, molecular formula, we are done with limiting region, percentage yield, stoichiometry basics, and the three formulas for moles. Now sometimes they ask us this thing as well, that find the percentage composition. Percentage composition. They'll directly ask us find percentage composition of Na in Na2SO4. So this is basic maths. Find out the mass of Na is in this compound. There are two atoms of Na, so 2 times 23. Out of the total mass of Na2SO4, I think it should be 64 plus 32. Still I'm fact checking. So 142 grams into 100. That's it. If they're asking find percentage composition of sulfur in this compound, how many sulfur do we have in this compound? Only a single sulfur. So mass of single sulfur is 32 divided by the total molar mass, which is 142 into 100. That's it. If they're asking find the percentage composition of oxygen in this, how many oxygen do we have? We have 4 oxygen atoms. 4 times 16 equates to 64 divided by the total molar mass, which is 142 times 100. So 64 by 142 times 100. This will give us the percentage composition of oxygen in this compound. That's it. So these were all the basics and the major topics of stoichiometry that will help us. So that's it for this video. Any doubts, do let me know in the comment section. I'll be more than happy to answer your doubts. Till then, I'll see you in the next video.